All right, today we are doing section 2.2. We are solving inequalities involving addition or subtraction. So that is our objective, to solve inequalities involving addition or subtraction and solve real-world problems involving inequalities. For our warm-ups, these are just equations. We've done these before. How am I going to get x alone on number 1? Good. Subtract 2, but if I do it on one side, I have to do it to the other, and that leaves me with x equals 1. Good. Okay, on number 2, what do I need to do to both sides? Jermila, good. Add 5. And we get y equals 14. Good. Number 3, how are we going to get y alone? Good. Subtract the 4. Good. 2 equals y or y equals 2, either way. Okay, when we took our test over these, some people had trouble remembering to subtract. If that number's positive, to zero it out, we have to subtract it. On number 4, we are trying to get x alone. What do we need to do to make that happen? Good. We need to move things away from the x. So the first thing we need to move is the 2r. It is positive, so to move it, we subtract it. Okay, so that leaves us with s minus 2r equals 3x. Liam, what's next? Good. We're multiplying x by 3, so to undo that, we divide by 3. And for our answer, we get x equals s minus 2r all divided by 3. Questions on our warm-ups? All right, most of these symbols you should already have from yesterday. Okay, and inequality is the relation between two expressions that are not equal. The only symbol here that we did not talk about yesterday was the not equal symbol. Hunter?
You went on homework from last night.
No, that's why we took a homework check. Okay, so if you need to get these symbols down again, that's fine. But we have most of them from yesterday. The only one we didn't have was the not equal symbol. All right, to solve inequalities, we use the same methods that we used to solve an equation. So this number 1 was our first warm-up. We had subtracted 2 on both sides of the equal sign. We got x equals 1. We just did that problem. So if we are going to solve x plus 2 is greater than 3, we're going to treat it very similarly to what we did over here. We're still trying to get x alone. So we're going to subtract 2 on both sides. But this time, instead of an equal sign, we still have a greater than sign. We've got a 1 on the other side. So solving an inequality is very similar to solving an equation. The only other difference that we have with inequalities is that we can then graph our answers. So we'll put it on a number line. Where is my circle going to go? On the 1. Is it open or closed? Open, because there is not an equal to bar. And am I shading left or right? To the right. Okay, next one. Again, we did this in the warm-ups. We subtracted 4 from both sides. We had gotten 2 is equal to y. We're going to do the same kind of thing for an inequality, but instead of an equal sign, we've got another greater than sign. So I subtract 4 on both sides. I still get a 2. Y is still alone. We just have a different symbol in the middle. But before I can graph this one, what do I need to do? Switch it. We need the variable to be on the left side. Okay, so if I switch the y and the 2, what else has to switch? The symbol in the middle. So it's going to flip around the other way. Now instead of a greater than symbol, we have a less than symbol. So I go to my number line to graph it. Where is my circle going? On the 2. Open or closed?
Why are you switching?
Open. We need our variable to be on the left side.
Okay.
So if we switch the variable over, the symbol in the middle switches. Okay, there's no equal to bar, so we put an open circle. Are we shading left or right? Left, because we have to go from what the symbol is after we switch it around. So we have to go with that less than symbol, which tells us to shade left. So we are going to try a couple without looking at the equation version of it. I'll write it a little bit bigger in case it's hard to see. All right, on this first one, how are we going to get x alone? Add 6. So we have to do that to both sides of that inequality symbol. So it happens to the -6. It also happens by the -10. If you still need to put a line through to show your two different sides, you can do that. If you still want to put a line through that symbol, you can. After we do that, we have x is greater than or equal to what? -4. Okay, again, we can graph that on a number line. Okay, this time I'll put 0 on the right side. 2, 3. Squeeze it in there. All right, am I having an open or closed circle on my -4? Closed because it has that equal to bar. And are we shading to the left or the right? To the right because it's a greater than symbol. All right, on the next one, how am I going to get b alone? Add 2 on both sides. I get b is greater than -7. Okay, again, when we graph these, especially for something like a -7, we might not want to count by ones. So maybe we count by 2s. If we count by 2s, where is our point going to have to go? In between which two numbers? -6 and -8. Okay, so if you need to change your scale to fit it on there, that's fine. We don't have to count by ones. But in this case, our point would go between -6 and -8. Is it going to be open or closed? Open. And are we shading left or right? To the right because it's greater than. What did we do to get m alone? Add 3 on both sides. When we do that, we have m is less than or equal to 8. When we go to graph that, do we want an open or closed circle at 8? Closed, because it had the equal to bar. And which way are we shading? To the left, because it was a less than symbol. Questions about number 3?
So if it don't got the equal sign, it's closed.
If it has the equal sign, it's closed. So it had the equal bar, so we filled it in. If it does not have the equal bar, that's when we leave it open. On number 4, how did we get y alone? We add the fraction, good. So we have to add 1/4 to both sides. Does anybody know what we get if we take 1/4 plus 1/4? Dominic?
1/2.
1/2, good. We do get 2/4. So if you got 2/4, that's good. We add the ones, keep the denominator, but that will simplify to be 1/2. So we get 1/2 is greater than y. Is this set up for us to graph it yet? No, we need to do what? Switch it around. We need the variable to be on the left. So when we switch the y and the 1/2, what else switches? The symbol flips around, so now it's a less than. So this is what we're going to be graphing. We can ignore the other one. Where would I find 1/2 on this number line? Okay, halfway between 0 and 1. Does it get an open or closed circle? Good, it gets an open circle because it does not have the bar under the inequality symbol. Shade to the left, good. We have to base where we shade on when the variable is on the left side. So that would be less than, shade to the left. 5 and 6 are going to be similar, except this time to get the variable alone, we will have to use subtraction instead. So this time we're undoing addition. So we're trying to get rid of the 8. We're adding it.
-8.
So we would use a -8. Yes, I'll write them bigger. Y plus 8 less than or equal to 5. This one is -8 is less than 1.4 plus m. So yes, to get the variable alone this time we use subtraction. So on number 5, when we subtract 8 on both sides, we get y is less than or equal to -3. And then we would want to graph that. Open or closed at -3? Closed at -3, shaded to the left because it is a less than symbol. On number 6, how are we getting m alone? Good. Subtract the 1.4 on both sides. Does anybody know what -8 minus 1.4 is? Good. -9.4 is less than m. Is that set up to graph? No, we need to flip it all around. When we flip it, the sign flips too. So if it was a less than sign, now it's a greater than sign. The whole thing flips. All right, on this one, I think I'm going to go by 2's. -10. Where would -9.4 land? Good, in between the -8 and -10. Pretty close to the middle of them. Okay, not quite closer to the 10, probably a little closer to the 8. No, I lied. That'd be a little closer to the 10. Anyway, it's going to be in between those. As long as you're in between them on a graph this size, that would be fine. Open or closed? Open. Shaded to the right because after we flipped it, it was greater than. Always go by whatever you have after you flip it around. Questions, concerns? Ready for another problem or two? Okay. Not hearing any protests, so we'll move on. I will write them bigger. I want you to try them on your own real quick. All right, on number 7, how are we getting K alone?
Subtract.
Good. Subtract 5 on both sides. We get K is less than or equal to? -8. When we go to graph, do we want open or closed at -8? We want closed because it's got the bar. Are we shading left or right? Left because it is less than. On number 8, how are we getting P alone? Yes, we subtract the 0.7. We get P is greater than -3. Open or closed at -3? Open. It does not have that bar. So we leave it open and we shade to the right because it is greater than. Good. So we want numbers bigger than -3. Good. Number 9 says you're going to take a flight to New York City to see a Juice WRLD concert. Your suitcase can weigh no more than 50 pounds. Okay, no more than 50 pounds. Your suitcase currently weighs 32 pounds. So, I would maybe make a note. Must be less than, how much did I say? 50 pounds. And it is currently how much? Okay, currently 32 pounds. So I'd maybe be making these notes. You're worried that the rest of your clothes and electronics won't fit. So letter A says write and graph an inequality that represents how much weight you can add to your bag. Okay, so we start with what we currently have, which is how much? 32. Plus, do we know how much we're adding to it yet? No. So what do you think we need? A variable. What do you want to use? X, sure. Okay. That must be less than how much? 50. So we took the information they gave us. We were able to write an inequality. However much is already in there, plus however much we add to it, has to be less than 50. To solve that inequality, what would I do? Good. If we're going to graph it, we have to solve it. So we subtract 32 on both sides. We get x is less than what? 18. Okay. One thing we should talk about real quick, though. Might change our answer a little bit. Could our suitcase weigh 50 pounds? Yes. So what should I be adding to these symbols? The line. So if it could be 50 pounds, we should add that symbol. They said no more than 50. It could be 50 pounds, but it can't be anything over it. So that will affect our graph, so it's a good thing we added it in there. On my graph this time, I'm going to count by sixes just because that'll make it so I don't have to make a million little tick marks. Do I want to open or closed at 18? Closed, shaded to the left. So this graph shows all the weight that we could add. We could add nothing, 3 pounds, 6 pounds, 8 pounds, all the way up to 18 pounds, but nothing more than that. Does that make sense? Okay. All right, question B is asking, can we add both a 7-pound laptop, so the laptop is 7 pounds, and an 8-pound pair of Timbs? I'm just going to put shoes. I told you I didn't write it, but, you know, trying to be hip, I guess. Okay? Could we add both of those without going over the weight limit?
Yes.
Why?
Because they equal it to 15.
Okay, so if we add these together, we get 15. And 15 is less than 18. So 15 is less than or equal to 18. Yes, we could add both our laptop and our Timbs. All right, error analysis. Describe and correct the error in solving and graphing. If you don't get this one written down, not a huge deal. But let's just look at what they did. You don't have to write it, but I do want to talk about it. So we need to be paying attention. So they started off with an inequality. What would you do to both sides to solve it?
Add 14.
They were taking it away, so we would add it. And it looks like that's what they did, so that's good. They combined their like terms correctly. So then they graphed it. What should they have done before they graphed, Lydia? They should have flipped it around. So when we flip it around, okay, there are two things they did wrong. What's wrong with their circle? It's not open. They should have had an open circle. And which way should they have shaded? To the right. So they actually made two mistakes there. So on your homework, if you have an error analysis problem like that, that's what they're looking for. Look at what they did, compare it to their graph, and what they should have done, what they should have gotten. All right. Let's get our homework up there. We are in section 2.2. We're doing all of 1 through 6, 7 through 29 odds, and also number 30.